Good day, guys. This is George Jan City Pass from BSG2A, and I'm here. I'm going to discuss and to show you how to solve different topics in engineering mechanics. So let's start. The first problem that we have is that to find the resultant of concurrent force system shown in the figure. So this is the figure, guys. Okay. The first thing that we must do is to find the summation of forces in x-axis. So in order for us to find the summation of forces in x-axis, we will just simply write 300 minus 100 cosine 30, 100 cosine 30 minus 200 cosine 60 plus 200 cosine 60, 200 cosine 60. So here. So why we use negative sign here? Because as we can see, the 100 force, the 100N is on the left side, and it is the same in the 200 cosine 60 because the 200 is on the left side. If the number is on the right side, it is positive, but if it is in the left side, it's negative. So let's continue. So we will just use the calculator to find the problem here. So the answer is 213.4 N. So we now get the summation of forces in x-axis. So we will proceed to summation of forces in y-axis. So summation of forces in y-axis is equals to 100. Oh, by the way, guys, I forgot. If you are getting the summation of x-axis, you will use cosine. But if you will find for the summation of y-axis, you will use sine. Okay, that's okay. 100 sine 30 minus this is 100 sine 30 200 cosine 60 sine 60 200 sine 60. Okay, that's all. Is equals to 200 negative 296.410 N. So we now get the summation of forces in x-axis and the summation of forces in y-axis. By the way, negative sign. Why negative sign here? Because as we can see, so hi again, guys. We will now continue. We already get the summation of forces in x-axis and the summation of forces in y-axis. So now we will get the resultant of the concurrent force system. Okay. In getting the resultant, the equation that we will use is square root of summation of forces in x-axis squared plus summation of y-axis, summation of forces in y-axis squared. So if we squared the summation is 213.4 plus negative 296.40410 squared, we will get 365.24 and down to the right, to the right. So we get now the resultant force. So that's all for problem number 1. Hi guys, we will proceed now to problem number 2, which is to compute the resultant of the 3 forces shown in the figure and locate its intersection with x and y axis. So okay, this is harder than the first problem. I will try to solve. In order for us to get the answer in this problem, we will get the summation of forces in x and y axis, and we will get the moment, and yeah, but I don't know if it is applicable. Yeah, you will use that, the moment, the summation of moment, when we are getting for the intersection of y and x. Okay, let's go. Summation of f x, or summation of forces in x axis, 400 is equals to 12 over 13 plus 750 over 200 over square root of 30 minus 350 sine 30 is equals to 875 wait 818 this calculator, this calculator, 0.27 pound to the right. It's to the right, yeah, it's to the right. And in getting the forces, summation of forces in y-axis, and now we use 400 multiplied by 5 over 13 minus 750 multiplied by 2 over square root of 30 minus 350 cosine 30. The answer is 565.29 negative 565.29 pounds. Negative means downward. So we will get the resultant of this problem, which is the resultant is equals to summation of forces in x squared, summation of forces in y squared is equals to 818.27 squared plus negative 565.29 squared is equals to 994.54. The resultant is 994.54. So before we get the intersection, we will also get the moment. Yeah, the moment. So let's proceed in getting the moment. In getting the moment, summation of moment is equals to 412 over 13 multiplied by 2 minus 400 multiplied by 5 over 13 multiplied by 5 plus 750 2 over square root of 13 multiplied by 4 minus 300 sine 30 multiplied by 2 30 is equals to 1183.33 feet per pound. Yeah. So when we are getting the intersection, we will first have a sketch. Um, yeah, we will draw first 0, I, X, I, Y, and the in the intersection where they go intersect the square X and the angle of Y. So in getting the moment or the intersection is the summation of moment over the summation of Y if you were getting the intersection of Y. So 183.33 over 565.29 is equals to 2.09 feet. Yeah, that's the intersection of Y. The intersection of X is equals to 1183.33 over the summation of forces in x-axis, which is 818.27 is equals to 1.45 feet. So now we complete and we have answered this problem. Thank you for listening. May God bless you. What's up, guys? We are done now into our third and final problem, which is this. Is about the truss and determining the magnitude of the resultant, its inclination with the horizontal, and where it intersects. AB. Okay. I will solve it in a different paper because it will not fit here. So okay, let's go. The first thing that we will going to do is to look for solve for the summation of x forces and the summation of y forces. Okay. In this problem, it is not the same in the past problems that we have solved. This is different. So okay. The summation of forces is equals to 3,000 plus 4,700 multiplied by 1 over square root of 5. The summation of EFX is equals to 5,101.91 pounds. 0.9 pounds. Okay, I'm sorry, my bad. And we will now get the summation of forces in y-axis. So negative 4,000 minus 3,000 minus 2,000 and minus 4,700 multiplied by 2 over square root of 5. The summation of forces in y-axis is equals to negative 13,203.8, and the negative sign indicates again it means downward. So we will get the resultant of these forces. The equation in getting the resultant is R is equals to square root of E forces of X, or the summation of forces in X, plus E the summation of forces in Y, okay, squared. So 5,101.9 squared plus negative 13,203.8 squared. So the answer is, we're just going to calculate it. The answer is 14,155.2 down to the right again. We will proceed now in getting the moment again, just like the past problem that we have solved. In getting the moment, we will use moment of A, 4,700 multiplied by 1, oh well, yeah, 1 over square root of 5 multiplied by 5 plus 4,700 multiplied by 2 over square root of 5 and multiplied again by 10 plus 3,000 multiplied by 5 and 4,000 multiplied by 10 plus 3,000 multiplied by 20 plus 2,000 multiplied by 30. Yeah, it's quite long, but it's okay. The answer is, it might take some time because it's so long. Okay, the answer is 227,547.6 pounds. In getting the x, we will just divide the summation of moment in A over the summation of forces in Y. So we will just input it in calculator and find for the x. $227,547.6 over 13,203.8 pounds is equals to 17.2 feet right of A. So that's all, guys. Thank you for watching. To God be the glory.